Hello, welcome to all of you. Now we discuss multiple choice question 2020 paper CC-7 semester 3 B.Sc honors in mathematics, University of Calcutta. Question 1a 2020. If x square, x cube are three linearly independent solutions of a third order differential equation, then the Wronskian W of the function has value. These four options. Here three functions x square, x cube, w. This equals to function y1, y2, y3, y1 dash, y2 dash, y3 dash, y1 double dash, y2 double dash, y3 double dash. So we get this 3 by 3 determinant. After expanding, we get 2x cube. So correct option is first one, w equal to 2x cube. Next question, one of the points which lies on the solution curve of the differential equation y minus x dx plus x plus y dy equal to 0 with given condition y0 equal to 1. Now, comparing the given equation with m dx plus n dy equal to 0, then m equal to y minus x and n equal to x plus y. Then del y of m equal to 1 and this equal to del x of n. So the given equation is exact differential equation. Now integrating m dx as if y constant, so we get y constant, so here yx minus x square by 2, and for integrating n dy as if x constant, so here x constant, so x into y plus y square by 2, and omitting here the common term xy from the second integral because this term is present in the first integral. So we get the general solution of 1 is xy minus x square by 2 plus y square by 2 equal to c. C is an arbitrary constant. So 2xy minus x square plus y square equal to 2c. This is the general solution of the given equation. And from the initial condition, here this y0 equal to 1, we get the value of c equal to half. Then general solution becomes 2xy minus x square plus 1 y square equal to 1. And this is the particular solution. If we plot the point 2, 1, then on the left hand side, if we put the point 2, 1, so x equal to 2, y equal to 1 in the equation 3, on the left hand side of 3, we get this equal to 1 is the right hand side. So the point 2, 1 lies on this particular solution curve, this. So 2, 1 lies on the particular solution curve 3. So 2, 1 is the correct option. 3 is the correct option, 2, 1. Question C, if the integrating factor of x to the power 7 y square plus 3y dx plus 3x to the power 8 y minus x dy equal to 0 is x to the power m y to the power n, then value of mn is what? Here multiplying and the given equation with the integrating factor x to the power m y to the power n, we get x to the power 7 plus n, y to the power 2 plus n plus 3 x to the power m y to the power n plus 1 bracket close dx plus bracket start 3 x to the power m plus 8 y to the power n plus 1 minus x to the power n plus 1 into y to the power n bracket close dy equal to 0. This is an exact differential equation. So comparing with m dx plus n dy, so m equal to this part and n equal to this part. So del y of m equal to del x of n. Now del y of m, this with respect to y, partial differentiating with respect to y. So 2 plus n y to the power n plus 1 plus n. And so del y equal to this and del x of n equal to this. After simplification we get this. So here in the left hand side x to the power n plus 7 y to the power n plus 1, in the right hand side x to the power n plus 1 y to the power n plus 1, and this x to the power m y to the power n x to the power m y to the power n, and equating the coefficients of like parts of x to the power m plus 7 y to the power n plus 1 from the both sides, we get 2 plus n equal to 3 into n plus 8, and 3 bracket n plus 1 equal to minus bracket m plus 1. So we get solving two equations in mn. This after solving we get m equal to minus 7, n equal to 1. So the correct option m equal to minus 7 1, first option is correct. So m equal to minus 7, n equal to 1. Next question D. Let yx be the solution of the differential equation d2y dx square plus 5 dy dx plus 6y equal to 0, y0 equal to 1, dy dx at the point x equal to 0 equal to minus 1. Then yx attains its maximum value at this. The differential equation, the initial condition, yx attains its maximum value. So given equation is this. We can write this d square plus 5d plus 6 bracket close y, where capital D stands for ddx, and the auxiliary equation, this m square plus 5m plus 6 equals to 0, where y equal to e to the power mx is be a trial solution of this differential equation. So values of m are minus 3 minus 2. Hence the general solution of the given differential equation 1 is given by y equal to c1 e to the power minus 3x plus c2 e to the power minus 2x, where c1 c2 are arbitrary constants. Differentiating 2 with respect to x, we get y dash equal to minus 3c1 e to the power minus 3x minus 2c2 e to the power minus 2x. From the first conditions, this y0 equal to 1, we get 1 equal to this c1 plus c2 equal to 1, and second condition y dash equal to 0 equal to minus 1, we get 3c1 plus 2c2 equal to 1. After solving this, we get c1 equal to minus 1, c2 equal to 2. Hence, and this is the particular solution, y equal to minus e to the power minus 3x plus 2 e to the power minus 2x. And dy dx equal to 3 e to the power minus 3x minus 4 e to the power minus 2x. For optimum value of y, dy dx must be equal to 0. Hence, this equals to 0. Hence, solving we get 3x minus 2x e to the power this equal to 3 by 4. So e to the power x equal to 3 by 4. Hence, x equals to ln, that is log to the base e, 3 by 4. So this is the correct answer, x equal to ln log 3 by 4. Correct option is 2. Question E. Consider the differential equation a dy dx plus by equal to c e to the power minus lambda x. A, B, C are positive constant, lambda is non-negative constant. Then every solution of the differential equation approaches to c by b as x tends to plus infinity, where lambda is what? A given equation can be written as AD plus B bracket close y equal to C e to the power minus lambda x, where D stands for ddx. Auxiliary equation am plus b equal to 0, so am equal to minus b by a. Complementary function of 1, yc equals to a capital A e to the power minus b by ax. Capital A is an arbitrary constant. And particular integral of 1, this yp equals to 1 by a small a capital D plus b c into e to the power minus lambda x. So this equals to c to the power minus lambda x by a minus a lambda plus b, where b minus a lambda not equal to 0. So yp equal to this. Hence general solution of the equation 1, y equal to a e to the power minus b by ax plus c e to the power minus lambda x by b minus a lambda. So we can write this c by b e to the power minus lambda x bracket 1 minus a by b lambda. Now x tends to infinity, e to the power minus bx by a tends to 0. So this part is 0 because a are positive constant. So e to the power minus infinity tends to 0. Now it is given that y equal to c by b as x tends to infinity. This question, this solution, every solution differentially approaches to c by b as x tends to plus infinity. So y equal to c by b. So when x tends to infinity, this part is 0. First part is 0. And for the second part, this c by b. So if it is only possible if lambda equals to 0. If put lambda equal to 0, so e to the power 0, this 1, and this lambda equal to 0, so this 1. So we get this equals to 1. So when x tends to infinity, y tends to c by b only possible if lambda equal to 0. So correct option is 2, lambda equal to 0. Question A. Which one of the following is correct for the linear differential equation bracket x square plus x bracket close d2y dx square minus 2 bracket x plus 1 bracket close dy dx plus 2y equal to 0? This is the ordinary point, regular singular point, irregular singular point, irregular singular point. Here, normalized form of the given equation by dividing of the given equation by x square plus x. So coefficient of d2y dx square is 1. So we get d2y dx square minus 2x plus 1 by x common bracket x plus 1 dy dx plus 2 by x common x plus 1 into y. So we get this 2 by x plus 1 y equal to 0. Here standard form d2y dx square plus p1 dy dx plus p2y equal to 0. So p1 equal to minus 2 by x and p2x equals to 2 by x plus 1. Now here x equal to 0 and x equals to minus 1 are singular points of the differential equation 1. Because here in this p1x, this x is in denominator, so x equal to 0 singular point. And here factor x plus 1, so x equal to minus 1, this denominator for this denominator part, for this term x equal to minus 1 is a singular point also. And both functions p1 p2 are non-analytic point at x equal to 0 and at x equal to minus 1. Now this x minus 0 for this x equal to 0, x minus 0 p1x, x minus 0 p1x, that means x into p1x, that is minus 2 by x, so equal to minus 2. And x minus 0 square p2x, so x minus 0 square means x square, so x square into 2x x plus 1, so x cancels, so x 2x by x plus 1. So obviously this x minus 0 into p1x and x minus 0 square p2x are both analytic at x equals to 0. So x equal to 0 is a regular singular point. Also for this point x equal to minus 1, so x plus 1 p1x, this is equal to this, and x plus 1 whole square p2x, this is equal to this. Both x plus 1 p1x and x plus 1 whole square p2x are analytic at x equal to -1. So x equal to -1 is a regular singular point. So both are regular singular point. So here 0 is ordinary point, no. This -1 is a regular singular point, yes. And 0 is irregular singular point, no. -1 is irregular singular point, no. So correct option is 2. So option 2 is correct. So -1 is a regular singular point. Next question G. The initial value problem x dy dx equal to y 0 equal to 0, x greater than equal to 0 has no solution, unique solution, exactly two solutions, uncountably many solutions. Here x dy dx equals to y. After separating of variables, dy y equal to dx by x, integrating log y equal to log c, log x plus log c. C is arbitrary constant. So y equal to cx. So y equal to cx is a straight line passing through origin. So this is y equals to x for parameter, any parameter c. So this passing through origin. So now initial condition is y 0 equals to 0. So y 0 equal to 0, we cannot determine the value of c because put here 0. So this is equal to c into 0. So 0 equal to 0. So I have no value of c. So c is an arbitrary value. So for any line passing through this origin, this uh, we get so uncountably many solutions for this differential equation, and this initial value problem has uncountably many solutions for this for any value of c. Correct option is 4. Next question. Double limit xy tends to 0 0 mod x by y square e to the power minus mod x by y square does not exist, exist and equal to 0, exist and equal to 1, exist and equal to -1. Here function fxy equals to mod x by y square e to the power minus mod x by y square. Although the curve, along the curve x equal to ay, a not equal to 0. So put x equal to ay. So y tends to 0, f of ay comma y. So put ay. So this x equal to ay, put this, so mod a mod y minus e to the power minus ay. And this part equal to 0, y tends to 0, e to the power minus ay tends to 0, this in minus infinity, to the power minus infinity, so this equal to 0. So this limit equal to 0, double limit. Along the curve x equal to y square, xy tending to 0, 0. So a put x equal to y square, so a y square comma y tends to 0. So this 1 by e is not equal to 0. So along the curve x equal to ay, along the curve we get the double limit 0, and along the curve x equal to y square we get the value of double limit 1 by e. Hence double limit xy tends to 0 0 fxy is not unique, so double limit does not exist here. Correct option is does not exist, this option 1. Question I. Consider the function fxy x square minus 4xy plus 4y square plus 2x to the power 4 plus 3y to the power 4. Then f has no extrema at 0 0, f has maximum value at 0 0 which is 0, maximum value at 0 0 which is 1, minimum value 0 0 which is 0. Here fxy equal to this. First we find del f del x, that is fx, and del f del y, that is fy, del 2f del x square, that is fxx, del 2f del y square, that is the fyy, and del 2f del x del y, that is fxy equals to -4. Now for extremum, that is either minimum or maximum, we must have del f del x equals to 0 and del f del y equal to 0, that is fx equal to 0, fy equal to 0. So we get 2x minus 4y plus 8x cube equal to 0 and minus 4x plus 8y plus 12y cube equal to 0. Obviously 0 0 satisfies the above system 1. So obviously 0, 0 is a stationary point. Now, this function capital H is equal to fxx into fyy minus fxy square. So find this fxx fyy minus 16, that is equal to xy square, that is minus 4 whole square, this minus 16. So we get this after simplification 24 into 8x square plus 3y square plus 36x square y square. Now h 0, 0 is equal to 0. Hence the case needs further investigation. Now we see that f0, 0 equal to 0 and fxy equal to this. Now fxy minus f0, 0 this equal to x minus 2y square plus 2x to the power 4 plus 3y to the power 4 is greater than equal to 0. Obviously, this is the square term, this to the power 4, this to the power 4, obviously greater than equal to 0. Actually, here fxy can be written as x minus 2y whole square, because fxy is here, this term, this x square minus 4xy plus 4y square, this term can be written as this x minus 2y whole square. And for all values of xy in the neighborhood of 0, 0. So if xy greater than equal to f0, 0, that is equal to 0 for all xy in the neighborhood of 0, 0. So if xy is greater than equal to f0, 0. So if f has the minimum value at 0, 0 and this value is 0. So correct option is this, f has minimum value at 0, 0 which is 0. Next option, next question J. Capital T is a function of xyz, xy square plus 2z minus x square z square with the temperature at the point xyz. The unit vector in the direction in which the temperature decreases most rapidly at 1, 0, minus 1 is what? Here, gradient of T, that is grad T is del x T I cap, del y T j cap, del z T k cap. So we get this value, this gradient of grad T equal to this. So grad T at the point 1, 0, minus 1. Put x equal to 1, y equal to 0, z equal to minus 1. So we get minus 2 I cap plus 4 k cap. I cap, j cap, k cap are the unit vectors along the axis. Now the unit vector in the direction of grad T, that is equal to grad T by modulus of grad T. So this is equal to minus I cap plus twice k cap by root 5. Now the temperature decreases most rapidly in the opposite direction of grad T. That is in the direction minus of grad T. Temperature decrease most rapidly in the opposite direction of grad T. So increase or raise the temperature in the direction of grad T. So decrease the opposite direction of grad T, that is minus grad T. So here question is the in which direction temperature decreases most rapidly. So direction is minus grad T. In this direction, minus grad T, temperature decrease most rapidly here. So this is the unit vector direction is this. This is the along the grad T. So obviously minus of this grad T. So actual answer is I cap minus 2 k cap by root 5. So option is 2. Correct option is 2. Now we can try geometrically this value of this x square minus 4 plus 4xy from GeoAlgebra or Desmos app, Desmos 3D graph. this equal to x square minus 4xy, x square minus 4xy plus 4y square, 4y square, 2x to the power 4 plus 3y to the power 4, 2x to the power 4, 2x to the power 4 plus 3y to the power 4. Actually, this is the curve and z equals to this. So for this question, this is the x-axis, this is the y-axis, and this is the z-axis. So in this, from this figure, three-dimensional figure, this question is this. The question is I. Consider the function fxy equal to this. Then f has minimum value at 0, 0, which is 0. Obviously, from the Desmos 3D graphs, we get three-dimensional surface. This obviously the surface, we find that 0, 0 is the minimum value for this curved surface, which is equal to 0, which is equal to 0. Obviously, this equals to 0. This point is 0. Thank you for watching this video lecture. Stop here.